Chapter 12 is the last chapter that we'll be covering, and this section focuses on trig functions. The trig functions that we'll be covering in this section are specifically for a right triangle, like the one shown here. And just to refresh on some terminology, we have a right angle here. The two sides that are next to or adjacent to that right angle are the two legs of the triangle. And then we have the hypotenuse. That's always across from that right angle. And the hypotenuse will be the longest side. We also have this symbol down here in the corner. This is the Greek letter theta, and that represents an angle, the angle that we're dealing with all our trig functions with. If you think back to geometry, you probably remember the phrase SOHCAHTOA, and that reminds us of the three main trig functions. So the first one is the sine, and that is opposite over hypotenuse. So if we're talking about the sine of theta, this angle here, it would be the opposite side, which is A, over the hypotenuse, which is C. The CAH in SOHCAHTOA is for the cosine. This is the adjacent over the hypotenuse. Adjacent is the side that's next to angle theta, which is, and tangent is opposite over adjacent. There's three new trig functions that we're covering in this section, and they tie into the old ones. So for example, there's something called a cosecant. We abbreviate this one CSC, and this is just 1 over the sine. Now remember, anytime we divide by a fraction, we keep it, switch it, flip it, which means we would take 1, divide it by the sine here. It's the same as multiplying by the reciprocal, and we end up getting hypotenuse over opposite. It's just the sine flipped. Next up, we have the secant. Secant is the inverse to the cosine, so we take the cosine, we flip it upside down, we end up with hypotenuse over adjacent. And lastly, the cotangent, flip the tangent over adjacent over opposite. The tricky thing about these is that you want to match up secant with sine and cosecant with cosine. It sounds like those should go together, but they don't. So when you're dealing with these new functions, just remember cosecant actually goes with sine, secant goes with cosine, cotangent, you can tell, goes with tangent. Now there are a few different types of problems you'll be asked in this section. The first is to find all 6 trig ratios. So here it gives us two sides of this triangle, both the legs, and it wants us to find all 6 trig ratios for that angle there, angle A. Also note, capital letters represent angles, so that would be angle A, angle B, angle C. Lowercase letters represent side lengths. This would be side C over here. And the first thing we notice is that C is missing. So let's find that first. We have a right triangle. We have 2 sides out of the 3, which means we can use Pythagorean theorem to find the missing third side. C is always the hypotenuse. Sometimes that's the one that's missing, other times it's not. In this case, we're plugging 6 and 8 in for the A and the B, solve for that missing variable, and we get C equals 10. Now we know those, we want to find all 6 of the trig ratios. So we'll start with sine. That's going to be opposite over hypotenuse. 8 over 10. Simplify all our fractions, and we get 4 over 5. Cosine is adjacent over hypotenuse. 6 over 10 simplifies to 3/5, and tangent opposite over adjacent, 8 over 6. Once we have these 3 beginner trig ratios, we can find the newer ones just by flipping what we have. So remember, sine goes with the cosecant. We just flip that sine upside down, and we get a cosecant of 5 over 4. Cosine goes with a secant. Flip the cosine upside down, we get 5/3, and cotangent and tangent are inverses as well. 3/4 for our cotangent. Instead of giving the actual image of the triangle, it could give us something like this, where it's telling us the sine of this angle is 6 over 12, and it wants us to find all 6 trig ratios, okay, or the remaining 5 after we have already been given the sine. So we know sine is the opposite over hypotenuse. We know that's 6 over 12, and we could use that to write a diagram. It doesn't matter how we draw this out. We just want to pick an angle. I have it in the top left here. Opposite is going to be 6. Hypotenuse is going to be 12. We fill those in. We want to find out what's this missing side over here, which is going to be B. B is opposite angle B. Side B is always opposite its angle. So we plug in everything that we have. In this case, we have that hypotenuse. So that 12 is going to go here. Okay, the A, it doesn't really matter if you have it in the A or the B for the 6. Either way, we have to subtract 6 squared from 12 squared. We get 108, and we'd have to do a factor tree on this. We would get 6 radical 3. So this is 6 radical 3. We know sine is 6 over 12. That simplifies to 1/2. Cosine, adjacent over hypotenuse, 6 radical 3 over 12. Simplify it, we have radical 3 over 2. Tangent, opposite over adjacent. You have 6 over 6 radical 3. These would cancel, 1 over radical 3. Now, we're not allowed to have radicals on the bottom, just like has been the case all year. So we have to rationalize this, multiply the top and the bottom by a radical 3, and we end up with radical 3 over 3. Cosecant is just the sign flipped upside down. 1/2 becomes 2 over 1. Secant, flip this guy upside down. Okay, it's going to become 2 over radical 3, and just like the tangent, we have to rationalize this. Multiply by radical 3 over 3, and we get 2 radical 3 over 3. Lastly, cotangent, flip this tangent, but instead of flipping this one and having to rationalize it by doing this, okay, we're just going to flip it before we rationalize it. So if we took this one over here and just flip that upside down, that gives us our simplified answer. Okay, this here would equal 3 radical 3 over 3. Cancel those to get this. Lastly, we could be asked to solve a right triangle. This means that we want to find all the missing sides and angles in triangle ABC. To start, easiest thing to find, we have 2 out of the 3 angles. We know that all 3 of these angles are going to add up to 180 degrees, so we can find angle A pretty easily. Okay, reminder, capital letters are used for angles. We just have to subtract these 2 angles from 180, and we end up with angle A equals 67 degrees. Now we want to find the 2 missing sides. Okay, so let's start with this adjacent side and the hypotenuse. Okay, adjacent and hypotenuse means we're dealing with cosine. Plug everything in. Now we know what the angle is. We know that the angle equals 23 degrees. We know that the adjacent side is 7. Hypotenuse, we don't know what it is. We'll call it C because it's opposite angle C. When we have a variable on the bottom, it's going to end up switching spots with whatever is on the other side of the equal sign. So C is going to equal 7 divided by the cosine of 23 degrees. We just plug that into our calculator and we get 7.6 for the length of the hypotenuse. Same idea to solve this other side. Side B, in this case, we have the opposite and the adjacent side. We're dealing with a tangent. Plug everything in again. And this time, since the B is on the top, we're just going to multiply both sides by 7. So 7 times the tangent of 23, we get 2.97. The smallest side should be across from the smallest angle. Okay, the largest side should be across from the right angle, since that'll be the largest angle. And then the middle angle and the middle side length should be across from each other.